So today we're covering 6.2, Introduction to Proportions, how we set these things up, how we solve them, and the types of couple story problems that we might be seeing, or types of story problems we might be seeing as well. So our main definition that we have for proportions, and this is the one that we're using for this entire section, it's a statement that equates two rates or ratios together. It's kind of our high-end, quote-unquote, definition of these things. If you want a more kind of quick, easy way of thinking of this, we're going to have two fractions set to be equal to one another, where one of them is going to normally contain an unknown, and that's what we're going to be solving for. So we're going to have a fraction is equal to a fraction. And again, the proportion is the idea of I'm given some ratio between two different things. We'll see this, I think this is really apparent in story problems where we see this play out. But we're given some sort of a ratio between these two things, and we're saying, okay, how are they equivalent to one another, if at all, or anything like that? And we're trying to figure out how they are and what ways we can solve for those. So one method to solve the scenario, or the scenario of having two fractions equal to one another, is to cross multiply. And this is one of the primary ones that we are going to be using as we go through these problems and these examples that we're going to be seeing down here. So the really nice part about this is it takes the fractions out of the problem that we're working with in one step, which is really, really nice. So the main way of doing this, we multiply across the equal sign to the opposite spot of the opposing fraction. So the numerator of one fraction is going to multiply by the denominator of the other fraction. The denominator of the first fraction is going to multiply with the numerator of the other fraction. And we'll go through and I'll show you guys some examples of this, but it's a really quick, really nice method to go through and take care of fractions, again, really easily. And I think just get those out of there altogether. Now, a very, very, very big warning to you guys with cross multiplying. Cross multiplication does not work with the equation if it's not exactly a fraction equaling another fraction. So let's say on the left-hand side of the equation, I have a fraction plus 3. And on the other side, I have just a fraction over there. A lot of people think, well, I've got a fraction over here on the left, I've got a fraction on the right, I can just cross multiply, even though there's a plus 3 in there. And we cannot do that. Cross multiplication is extraordinarily picky. We can only do it if we have one fraction equals another. If we do not have that exact scenario, we cannot cross multiply at all. And if you do, you're going to lose a lot of points on the homework. You're going to lose a lot of points on the test for that. So in general, here's what we have for our general equation with this thing and how it works out when we multiply things. Let me zoom this in here a little bit. So if we have a ratio set up as A over B is equal to C over D. So that's our initial ratio, whatever it may be. A can be anything from it's just a number, it could be a fraction, it could be some expression written in there, maybe x plus 1, doesn't matter. It's the same thing with B and C and D. But whatever it is that we have is a fraction equals a fraction. Could be a gross fraction, could be a really nice fraction, doesn't matter. It's a fraction equals a fraction. So to cross multiply, the numerator of one times the denominator of the other, the denominator of the one times the numerator of the other. So to cross multiply, this gets us A times D is equal to B times C. This is going to ultimately be our result when we do cross multiplication. And what's nice about this is this overarching scenario of a fraction equals a fraction has disappeared now. And we're just left with these two things multiplying equals these two things that are multiplying. Okay? So it gets rid of our initial scenario and takes a lot of the headache out of that for us. So we also get into this idea of if we do or do not have valid or invalid proportions. And this all stems from if we are checking our result or anything similar to that. So if the resulting products, like we have over here, are equal to one another, so AD, or A times D is equal to B times C, then we have a valid proportion, which means this fraction is indeed equal to this fraction, or at least equivalent to that fraction. Okay. If not, if I have the left side, let's say a times d is equal to something, and b times c is equal to something completely different, well, then I have an invalid proportion, which means these two things are not actually equal to one another, and the entire proportion is, again, invalid. So we're going to look at a couple scenarios here for what that does or doesn't look like. So we're checking to determine if each proportion is valid or not. So if we have 7 over 10 is equal to 14 over 21, is this a valid proportion? So our process for doing this, we're going to cross multiply. So our general idea of cross multiplying, just like we have up here, I'm doing 7 times 21, just writing that out, is equal to 10 times 14. Again, write that out for yourself. A lot of people skip this step in their process, and they just go right to, okay, multiply and multiply. And a fair amount of the time, I do see a lot of people be off ever so slightly with the numbers that they're working with because of that. So it's one extra line of work. I would highly recommend you do it, and then let the calculator multiply those together for you if you need to. Nothing wrong with that. And when we do multiply those, we get 147 is equal to 140. Now in this instance, the resulting products are equal. It's a valid proportion. Well, these things are not equal. If not, then we do not have a valid proportion. We have an invalid one. This is not a valid proportion based on our definition that we have here. Taking a look at example 2, we're going to set it up the exact same way. We cross multiply. I've set that up for myself right here. Multiply each side together, simplify that down. 5 times 24 is 120, excuse me. And then 8 times 15 is 120. The left side is equal to the right side, which makes this a valid proportion. These things are proportionately equal to one another. Okay. So now we're going to get into a couple scenarios, and these are the examples we're going to go through now, of how do I set these things up, and how you have these already set up, I should say. How are we going to go through and solve them? So we set up the proportion equation for ourselves, we cross multiply, and then solve the resulting equation that comes after that. So we're going to go through a couple of these. Might not go through all of them. We'll go through at least 3. Mostly because we do have story problems that have proportions showing up that I want to go through and give them their fair time. So we're going to jump on over to our whiteboard, but these are the problems that I'm going to be referencing over there. I'm saying examples 1, 2, and 3. Come on, computer, cooperate with me. There it goes. Okay. So our first example that we were working with from the solving proportions we had 5 over 4 is equal to 40 over m. Oops. Lowercase m. Okay. So we set up the proportion equation. We have a fraction equals a fraction. Great. Now, because I have a fraction equals a fraction, I can cross multiply. So there's a couple ways that people like to write this out for themselves. It's your call if you want to do this or not. I like doing it because it keeps my work organized and it keeps me knowing what I'm doing with this. We're taking the numerator of one, multiplying it with the denominator of the other. So I'm going to have 5 times m. So you can either write it out as 5 with a little dot and m. Your other option, and I recommend doing this when we have negatives showing up, is you can also do parentheses 5, parentheses m. And again, parentheses next to each other denotes multiplication. Now on the other side, we have 4 times 40. So we have that there. Simplify each side of the equation down before we do anything else. So 5 times m gives us 5m. On the opposite side, we have 4 times 40, which is going to give us 160, assuming my mental math is correct today. And now from here, we're just solving this equation for m. Our fractions are all gone, which is really nice. And we're referencing now our 3.5, 4.8, I think it was, material, all that stuff that we've been doing up till now. So I do not want 5m, I just want m, so I'm dividing both sides by 5. I'm going to get m is equal to, use your calculator if you need to, that's what I'm doing off screen. I'm getting 32. So we have our answer there. Take a look at our second example that we have, again from that same grouping. And we're starting with t over 9 is equal to 10 over 45. So again, just like our previous example, we're looking to see I have a fraction equals a fraction, which is great, so I can cross multiply. So writing that in for ourselves. So I have 45 times t, and I have 9 times 10. Simplify each side, so I have, on the left side, I have 45t. On the right side, we're getting 90. And then divide both sides by 45. Forty-fives cancel on the left, getting t is equal to 2. And we get our answer there. So again, I think this process, once we do the setup, once we have a fraction equals a fraction, it's fairly straightforward, and we're seeing that based on the problems that we're getting and our process once we have cross multiplied, we're basically using the material that we learned from previous chapters and just applying it here now. So our third example that we have, and this is when I wanted to see some of the weirder ones that show up, but very important that we do see this. So I wanted to go through it. Okay, so we're starting with 4x minus 3, all divided by 2, is equal to 15 over 6. Now it's very, very understandable and very reasonable to say, okay, well, Alex, you said we need to have a fraction equals a fraction to be able to cross multiply. Well, the numerator of this thing that we have over on the left side, well, we have addition and subtraction going on in there, so we can't use cross multiplication. That is an extraordinarily reasonable assumption to make based on the problems that we've been working with and this new problem that we have now. However, we are actually okay to cross multiply in this problem because of the fact that that addition or subtraction going on is all contained within the numerator of that fraction. So there's a very big difference, and I'll put this off to the side here, make a quick note to it. There's a very big difference between having 4x minus 3 over 2, make this 3 a bit better. So 4x minus 3 over 2 versus 4x over 2 minus 3. So in our first scenario that we have, everything is contained within a fraction. That minus 3 is all within the numerator of what we are working with. In the instance that we have on the right side over here, we have a fraction minus something else. So the example on the right is an instance where we do not have a single fraction, right? Oh, we do not have only a fraction on one side. Our left example, it's just a grosser looking numerator than what we may want or like to work with. Okay. So bringing us back to our problem that we were working with, we do have a fraction equals a fraction, so we can still cross multiply here. Writing this out. And again, I highly recommend when you are doing this, take the one extra line of work to actually write out what's multiplying together. I think it's really helpful, especially with problems like this. And now we're going to, on the left-hand side, we're distributing. The 6 is going through to every term inside the parentheses. So we're going to get 24x minus 18 is equal to, and on the right-hand side, we're just getting 30. Now again, our rules for solving this, because the fractions were taken care of after the first step, we're just solving this thing as if it were a 3.5 or a 4.8 problem. So I'm just going to be solving this thing for x. A lot of this should be review from what we've done in the past. So I'm going to kind of go through this at a little bit quicker pace. So that way we are having time, or going to have time to go through story problems. We're getting x is equal to 2 for our final answer. Okay. And if you're someone who would like to go through and give example 4 from this group of examples we have a shot, you're going to be doing an extraordinarily similar process to what we have here. Again, example 4 is working with a fraction equals a fraction. The numerator of the fraction on the left-hand side does have addition contained within it, which is fine. It still keeps us as having a fraction equals a fraction. And reference our examples, or this little set that we have here. So here, our left example, we can cross multiply. The right example, we cannot cross multiply. Okay. So I'm going to jump us back to our lecture notes because I do want to at least take a look at, oops, where are we at here? That's the one that we have. So jumping over to some of the story problems that we're working with. So we have a couple of these set up for ourselves, but I do want to make a couple notes before we go through these, at least highlight these a little bit before we go into solving these ones out. So the main goal with these, again, because we're working with proportions, our goal is to try and set up fractions to be equal to one another and then solve that proportion that we've set up. So my goal is to have a fraction equals a fraction. We don't know what necessarily is going to go in the numerator or the denominator. That's fine. We have ways of going through and doing that. Most of these story problems that we're going to have are going to have units attached to them. And I highly recommend when you are going through these, label the units of the numerator and the denominator to make sure that you are plugging numbers in correctly. It doesn't matter how they're labeled. So if you choose to have one unit in the numerator, but I've chosen to write the problem out with that unit in the denominator spot, it doesn't matter. You will still get the exact same answer as long as you stay consistent with that throughout the entire problem. So these little bits of initial setup that we do go a very, very, very long way as we're solving these ones out. And I'll get to what I mean by labeling the numerators and the denominators when we get into these examples, which we're going to go through here right now. So our first example that we have Todd Gurley has 415 rushing yards in his first 5 games of the 2018 NFL season. How many rushing yards would he have after 10 games, assuming his yards per game stays consistent? So this is the problem that we're going to work with. I'm going to jump us over to our whiteboard and how we set this thing up. This is the problem that I'm referencing over there. So So we'll move us down over here. Oops. Come on. There we go. So our first story problem that we have. So again, our ultimate goal is we want to have and set up a proportion for ourselves. So we want a fraction equals a fraction. My recommendation to you when you're going through this, start by just making that for yourself. Put a fraction equals a fraction. We'll figure out what's going to go where after we've done some labeling. So we want a proportion. There we have the general setup of a proportion made for ourselves. So reading the problem again with story problems, read, reread, and reread again. So Todd Gurley has 415 rushing yards in his first 5 games of the 2018 NFL season. How many rushing yards would he have after 10 games? So we're trying to figure out, okay, what units are we working with in this problem? And the two that we have are rushing yards and games. Now, because we have those two units, we need to decide for ourselves what unit is going to represent the numerator numbers, what unit is going to represent the denominator numbers. It does not matter which one you choose to be in the numerator or the denominator spot. All you need to do is pick which one is going where and then stay consistent on plugging numbers in throughout the rest of the problem. So I am going to choose to put the rushing yards in the numerator spot. I'm just going to label that off to the side and say R yards for rushing yards. So rushing yards is going to be up top. And the other unit that we have that's relevant to this is the number of games that have been played. So rushing yards up top, and I'm just going to put games down below. Okay. And again, you're more than welcome to reverse those if you'd like to. Doesn't matter which one goes where as long as the units and the numbers line up accordingly. So our first scenario that we've been given, we're told Todd Gurley has 415 rushing yards in his first 5 games of the 2018 NFL season. So I'm plugging in the 415 rushing yards in his first 5 games. Now we're being asked, how many rushing yards would he have after 10 games? So we know the number of games that we're going to try and be proportionate to. So we have 10. We do not know the rushing yards that he's going to have for that. That's what we're solving for. So we can fill that in with an unknown or a variable. So you can do X, you can do A, you can do M. I'm going to do Y for yards. But whatever you want to label that variable as, it's your choice. So now we have a proportion set up for ourselves. In 5 games, he ran 415 yards. In 10 games, he ran Y many yards, which is exactly what we're going to solve for right now. So again, I have a fraction equals a fraction. I can cross multiply. I'm going to write this out for myself. So I have 5 times Y is equal to 415 times 10. Just simplify both sides. And again, now we're doing the exact same process that we were doing above. We've taken the story elements out of this thing, and we're just working with a nice mechanical problem. And 4,150, I don't know what that is off the top of my head. So I'm going to use a calculator to find out what that is. And you're welcome to do the same thing. I'm getting 830. So after 10 games, Todd Gurley is going to have 830 rushing yards for the season. Okay. And that similar that process that we went through to set this thing up for ourselves is pretty much what we're going to be doing with all of the rest of these story problems that we have. Just doing a lot of that initial setup work for ourselves and then working on it from there. So I'm going to jump us back to our problems that we had, so which one we're referencing. So looking at problem 2. Ordering 2 large pizzas with 3 toppings each cost $13.24. How much would it cost, or should be how much? I do math. I don't do letters and English stuff as well, clearly. How much would it cost to order 6 pizzas? We're told to round your answer to the nearest penny. So this is assuming that we're probably going to have a decimal answer showing up. So round the nearest penny, you're probably going to end up rounding to 2 decimal places if we get decimals showing up with that, which we probably will. Okay, so this is our example that we're working with. I'm going to jump us back to our whiteboard. And again, our goal is to set this thing up to be a proportion. So I want a fraction equals a fraction. So I'm just going to make that for myself right off the bat. So fraction equals fraction. Next, label for yourself what are the units that we're working with that are relevant, and which one is going to represent the numerator, which one's going to represent the denominator. So looking at this, ordering 2 large pizzas with 3 toppings each costs $13.24. How much would it cost to order 6 pizzas? Okay. Yeah, here. Sorry, my other screen is being a little weird and not cooperating with me. Okay, so where are we at here? Okay, yeah, so equation 2, okay, sorry about that. Technical difficulties behind the scenes. So ordering 2 large pizzas with 3 toppings each costs $13.24. How much would it cost to order 6 pizzas? So our 2 units that we have are the cost in dollars and then the pizzas that we're having. So I'm going to put the pizzas down below because I feel like it. And I'm putting the cost in dollars up top. Okay. And again, you're more than welcome to reverse how you have those units set up for yourself. It doesn't matter as long as we have we stay consistent with what's being plugged in where with these. So our first scenario, 2 large pizzas with 3 toppings each. So the 3 toppings each, kind of irrelevant. We have pizzas and we have costs. That's the only thing we're caring about. So I have 2 pizzas, and they are going to cost $13.24. How much would it cost to order 6 pizzas? So if I have 6 pizzas, I don't know the cost, so I'm just going to write that in as a variable. I'm going to choose C to represent cost. And again, if you want to choose X or Y or your favorite variable, you're welcome to do that. You can get really fancy and use the Greek alphabet if you'd like to, but that's, again, optional. So we have a fraction equals a fraction, and now we just cross multiply and solve this thing out just like we were doing above. So these little bits of setup that we're doing, they go a very, very long way solving these things. At least I think they do. A lot of people, when they're going through these, they skip this step. They skip the writing out the units, writing out the fractions, doing that little bit of extra setup for themselves, and it costs a lot of people a lot of points because of that. Because at this point in time, now we're solving a problem like we've done with previous sections. Nothing particularly new about this. Again, these calculations that I'm doing with these larger numbers, I'm just using a calculator off screen. You're more than welcome to be doing the exact same thing, because I don't expect you guys to be able to do all of the decimal multiplication, division, all that in your head, because I can't do that. So use a calculator, make that easier for yourself. And after we go through this process, we're finding how much is it going to cost to have or to order 6 pizzas. It's going to cost $39.72. And thankfully, we didn't have to do any rounding for that, so we just get The cost is equal to $39.72. Okay. So our last example that we have, I'll jump us back to that. So on a map of Westeros, there's a spotlight here. On a map of Westeros, 1.5 inches is equivalent to 25 miles. What is 3.5 inches on the map equivalent to in miles? Round your answer to 2 decimal places. So up till now, if you've been looking at these previous examples and saying, well, okay, I could with this first one, I could just take the rushing yards and the games, I could just, because this is multiplied by 2, I could just multiply this by 2. This scaled up by a multiple of 3, so I could just scale this answer up by a multiple of 3. And theoretically, yes, you could. But the reason we went through these ones is because how could you scale this? It's kind of by 2. It's a bit more than 2, but how much more than 2? And it's a little, it's a non-perfect number in that regard. So if you're looking at these, well, I can just always take the smaller number and just multiply it by something to get the larger values that I have, or something to that effect. I'd be very careful with jumping to that is how I'm going to always solve these things, because I can give you some really gross decimals showing up that it's going to make that a heck of a lot more painful to do on that front. So that's why I went through kind of some bit more straightforward ones, and now we're getting to some grosser numbers that are showing up in here. But we're going to use the exact same process that we just did with 1 and 2. So jumping back to our whiteboard, but this is the example that we're using, number 3. So again, we were told on a map of Westeros, 1.5 inches is equivalent to 25 miles. What is 3.5 inches on the map equivalent to in miles? Okay, so again, we have a proportion. We want to work with a fraction equals a fraction. So we're just setting that up for ourselves right from the beginning. What are our units? We have inches and we have miles. Doesn't matter which one we put where in the equation. We just need to pick which one's going in which spot, and we go from there. So I'm going to put inches up top in the numerator spot. And I'm going to put miles in the denominator spot. And again, you can reverse this if you'd like to. So our first fraction, on the map of Westeros, 1.5 inches is equivalent to 25 miles. So I have 1.5 inches, 25 miles. What is 3.5 inches on the map equivalent to in miles? So I have 3.5 inches equivalent to, and I don't know how many miles it represents. I'm going to use m to represent that unknown. So now I have my proportion set up. I have a fraction equals a fraction. And now I'm just cross multiplying, and now it's a mechanical problem like we did before. Not a whole lot else that's going on with that. And again, I highly recommend to everyone, do that initial setup process of making the fractions for yourself, putting the variables written in. See, a lot of people fight that and say, well, I don't want to write those in. I'll just keep track of it in my head. And people lose points on that. So organization is a very, very, very important part of math. A lot of people do not realize that, unfortunately, until it's a little too late on a test or the homework or anything like that. Okay, so we are getting, after we go through this process, we're getting 58.33333, and so on. Continues on like that forever. Now the problem itself tells us round your answer to 2 decimal places. So when we round this, we are rounding to the 2nd decimal place here. I look to the decimal place 1 to the right of that. If that number is 5 or larger, I round up. If it's less than 5, then I round down and I leave the value that we're looking for exactly as it is. So when I am rounding this thing accordingly, I'm getting 58.33 for the final answer. Technically, this is approximately equal to, but same idea. And this is how we would go through and set up these story problems that we have been given. We'll zoom this out here a little bit. So again, as we're looking through these 3 story problems, a little bit cut off on the right-hand side there. But again, a lot of these we have very similar initial setups. Fraction equals a fraction. Label which unit goes on the top, which one goes on the bottom. Again, it doesn't matter which one you put where, just as long as you label one of them and then stay consistent throughout the problem. And after we've done that, we're doing the exact same thing every single time that we're solving this thing out. Not a whole lot changes. It's very mechanical in that regard. So this is everything for the 6.2 material. And again, I highly recommend when you get to story problems with these, make sure you're doing this initial setup for yourself. This goes a very long way in making these problems a heck of a lot easier. So that's everything for today. I'm going to stop the recording and take any questions that you guys have. We'll go from there.